In this video, I will show you how to solve limits in different ways. There are three ways to identify a limit of a function. The first way is doing it graphically, just like last time. The second way is solving it numerically. And the third way is going to be algebraically. Here I have the previous example, which is f of x squared minus 4 over x plus 2, where the domain is all the real numbers except for negative 2 because there is a discontinuity. We already know that the graph looks like a linear form and has a discontinuity at negative 2. However, as I said last time, we can see how the graph takes values of f of x around values of negative 2. So by solving the limit graphically, we're going to make an educated guess as the graph gets closer and closer and closer to negative 2 from both sides. We're going to get closer and closer and closer to a value in y, in f of x, which is going to be, as we saw last time, negative 4. So just by looking at it graphically, here I have a better graph. Desmos, we have the function x squared minus 4 over x plus 2, and I have here the point negative 2 comma 4. As you can see, there is a discontinuity, but when I highlight the point, you can see when x tends to negative 2, you can see that the f of x is tending to negative 4. So that's the first way of solving a limit graphically. The second way is going to be using a table of values numerically. For this, we're going to need a GDC or any calculator. We're going to do this by taking values close to negative 2, but not exactly negative 2, because taking negative 2 would invalidate the function. Taking values slightly smaller and slightly bigger than negative 2 is going to allow us to see what values the function is approaching. So we have f of x equals x squared minus 4 over x plus 2. So to solve it numerically, as I said before, we need a table of values. To make it easier, we're gonna take values smaller and bigger than negative 2 to understand the behavior around the values. So we're gonna start constructing our table of value. Here we have x and f of x. So we have, if we take negative 2, we know that that is undefined. But what happens when I take undefined? But what happens when I take values bigger than negative 2? So for example, if I take negative 2.5, if we let x be negative 2.5, then f of x is going to be negative 4.5, and I'm going to show you this on the GDC. We know that is x squared minus 4x over x plus 2. If we take negative 2, we're gonna have negative 2 squared minus 4 over negative 2 plus 2.5. I'm sorry. We're gonna have negative 2.5 squared minus 4 over negative 2.5 plus 2. We're gonna have negative 4.5. Now let's take one closer to negative 2. For example, negative 2.2. Negative 2.2. This, if we take f of x of negative 2.2, is going to be negative 4.2. Making it closer, even closer, is going to be 2.1. F of x is going to be negative 4.1. You might recognize that we're just where this is going, but for good measure, we're going to finish this second method using another method. In your GDC, we're gonna graph the function. I have here the function x squared minus 4 over x minus 2. So we're gonna press graph, and you have the function. So now, if you press second function and trace, I'm gonna write it over here. If you press the bottom second function, and then you press the bottom trace, second function, trace, you're gonna end up in this menu, which is calculate. In this menu, the first option, as you can see, is called value. This is to calculate values as we're doing just a moment ago, but way faster. We already took values smaller than -2. Now let's take values bigger than -2. But now we're going to use the calculator to make it faster. Now we press enter on the option of value. Now we're just gonna input the value that we want. So for example, let's try values like -1.5. We have -1.5. This is gonna be -3.5. Now let's try -1.8, one more closer to -2. I have -1.8. It's going to be -3.8. Now let's try -1.9. We're going to have -1.9, -3.9. So as you can see, with our table of values, as we approach to -2 from either value, you can see -3.5, -3.8, -3.9. If I make this -1.99, it's going to be -3.99, and so on. You can see that we are heading to -4. And from this side, as you can see, -2.5 is -4.5, -2.2, -4.2, -2.1, -4.1. If I make it -2.01, is going to be -4.01, which is basically -4. So we are also getting close to -4. As I said in the other video, we are converging to a value which is -4. Therefore, we can say the limit exists. The limit of this function exists, and it is -4. So this is the second way of solving a limit, which is numerically, or with a table of values, numerically. Now, let's take another approach to solving the limit. The third and final way I'm going to show you is going to be algebraically, solving limits. Algebraically. So what do I mean by algebraically? We're going to use the same example as before. F of x is going to be equal to x squared minus 4 over x plus 2. So, as you can see, if you haven't recognized something particular in this function, is that it can be factorized in the denominator. So what do I mean from this? If you remember in your Algebra 2 class, on the denominator over here, we have something that is called a difference of squares. A difference of squares is the following. So on the denominator, we're going to have x plus 2 and x minus 2. And on the numerator, we're going to have the same thing, x plus 2. So where do I get this x plus 2, x minus 2? You should remember this from your Algebra 2 class, but I'm going to remind it. So we have x plus 2, x minus 2. If you multiply this using distributive property, you're going to have x squared plus 2x minus 2x minus 4. 2 times 2 2 times negative 2, negative 4. So these terms in the middle I'm going to cancel out, and we're going to have x squared minus 4, which is what we have over there. So by solving algebraically, I mean we're going to rewrite the function as another equivalent function to be able to evaluate the function at the limit, because we're interested in the limit as x approaches negative 2. If we evaluate the limit as x approaches negative 2 using this function over here, we're gonna get a 0. But if we use the method that I just showed you, manipulating algebraically, now I wrote this upper part here differently using difference of squares. Now you can see here that we have x plus 2 and x plus 2 on the top and the bottom, so they cancel out, and we have only x minus 2 remaining. So I just manipulated algebraically to show you that x squared minus 4 over x plus 2 is the same thing as x minus 2. So now we can use this. Let's call this g of x. G of x is equals x minus 2 to evaluate the limit as x approaches negative 2 of x minus 2. So now that we have a new function that is exactly the same as the previous one, now we can start evaluating limits without getting invalidations. So I'm going to show you real quick that both these functions are the same. So here we have in decimals, we have the red line is the function f of x, where we have an invalidated function if we evaluate for negative 2. And now, as I claimed here, x squared minus 4 and x plus 2, manipulating it is going to be x minus 2. So if I write x minus 2, is the same exact function. So now we can evaluate the limit when it's negative 2. So we're going to do this by simply replacing negative 2 in the function. So we say that the limit as x approaches negative 2 of x minus 2 is the same thing as negative 2 minus 2, which is equals to negative 4. So negative 4, we got that solving it graphically and numerically. So we just proved that solving limits graphically, numerically, and algebraically gives the same result. We came to realize that the result is negative 4, and I'm going to be solving some exercises in the next video. Thank you.